Hi, in this video, we want to use matrices to solve a system of linear equation. In previous videos, we looked at how to use the Cramer's rule and also the Gaussian elimination method to solve a system of linear equation. And now we want to use matrices to solve the same question we've been solving there and see if we can arrive at the same answer. So the question x1 minus 4x2 minus 2x3 equal to 21. And then here we have 2x1 plus x2 plus 2x3 equal to 3. And here we have 3x1 plus 2x2 minus x3 is equal to negative 2. All right, so we want to use matrices, the method of matrices to solve this question. Now, this is quite simple. So what do we mean? So in normal algebra, so let's say we're given ax equal to b, where a and b are constant. So if we want to find the value of x, it's simply by saying x is equal to b over a, or we can write this and say b multiplied by a to the power of negative 1 using our law of indices. So all we need to do is this constant on the right hand side, we want to multiply it with the matrix or the inverse of this matrix on the left hand side. So once we can do that, then definitely we'll be able to arrive at the same answer. It's going to be a lengthy video. So you are endeavored, or it will be good if you've seen other videos where we talk about how to find the inverse of a matrix, how to find the adjoint of a matrix, how to find the cofactors of a matrix, because that's what we're going to be doing here, really. It's not difficult, but previous knowledge is needed in this video. Okay, so the first thing is to generate our matrix. So generating our matrix, we have a matrix of this form. So 1, 2, 3, negative 4, 1, and 2, and then negative 2, 2, and negative 1. Okay, so and the constants here. Okay, sorry, I didn't write the variables. Okay, so x1, x2, x3. Okay, so this will be equal to 21, 3, and negative 2. Okay, so quickly, what we want to do here is to find the determinant of this matrix. Remember, before we can find the inverse of the matrix, we need to find the determinant just to ensure that the matrix is not a singular matrix. If it is a singular matrix, then definitely it has no inverse. So after we're sure that it is not a singular matrix rather, then definitely we can move on to finding inverse using this formula that I've written. 1 divided by the determinant times the adjoint of the matrix. Okay, so without wasting much time, so what will be the determinant of this matrix? So we can use the long method or the shorter method. So I, for one, prefer the shorter method. So we can easily 1, 2, 3 minus 4, 1, 2. Okay, minus 2, 2, negative 1. Okay, 1, 2, 3 minus 4, 1, and 2. Okay, so yeah, multiply the leading diagonal. So 1 times 1 times negative 1. So that's minus 1. Okay, because this times this times this, minus 1, plus 4 times 2, 8. Of course, minus 8, 8 times 3, that's 24. So this is minus 24. Okay, that's perfect. Then lastly, 2 times 2 times 2. So 2 times 2, 4. 4 times 2, 8. Again, this is negative 8. So here we have, you can put everything here inside of the brackets, then subtract it from the multiplication of the backward diagonal. So 3 times negative 2, that's negative 6 times 1. Okay, so here we have negative 6 here. Okay, so 2 times 2 times 1. So 2 times 2, 4. 4 times 1, that's 4. Okay, and lastly, 4 times 2, 8. So that's plus 8 here. Okay, so try to simplify this. Simplifying this, we have, so I'll just do everything inside the calculator. Minus 1, minus 24, minus 8. So this one is minus 33. Then here we have minus 6 plus 4 plus 8. We have minus 6. So this is minus. Okay, we have just 6. So minus 33, minus 6. So that's minus 39. So my determinant is negative 39. So I can clear this part now and then try to find the adjoint of the matrix. So I hope the method I use is quite clear. So if it's confusing, I showed there's a video concerning it underneath the determinant of a matrix where we did the shortcuts to finding the determinant of a 3 by 3 matrix. Okay, now to find the adjoint. Remember, before you can find adjoint, you have to find cofactors first. So for cofactors, Remember, sign plus minus plus, minus plus minus, and plus minus plus. So we are going to be multiplying the minor of this matrix with the place sign. Okay, just to generate our cofactors. So cofactor of this matrix would be, so let me take my okay, so by the time I strike this and then I strike this, what am I left with? So I'm left with 1, 2, 2, and minus 1. So 1 times minus 1, so that's 1 times minus 1, that's minus 1. Okay, okay. Then 2 times 2, that's 4. 4, yeah. So 4, so that's minus 1 minus 4, so that will be minus 5, isn't it? Okay, so let's just be sure. So 1 times minus 1 is minus 1, like we said. So let me write it here, minus 1. Okay, then 2 times 2, that's 4. So minus 1 minus 4, so that's minus 5. Okay, and then multiply with plus 1, so that's still minus 5. So write minus 5 here. Okay, next one, so strike this out, strike this out. So I'm left with 2, 2, 3, and minus 1. So 2 times negative 1, so it's minus 2. Okay, minus 3 times 2 is 6. Okay, so minus 2 minus 6, that's minus 8, isn't it? Okay, and then times this, so that's positive 8. So here I have 8 here. Okay, next one, for this one, so strike this, 2, 1, 3, 2. So this is 2, this is 2. Okay, was it 2 I used before? I guess so. Let me see. So when I strike this, okay, I wasn't using this. When I strike this, I used 1 minus 1, 2, and 2. Okay, okay. All right. So you have to be careful so you don't make any errors. Rather than being careful, because since it is quite long, so why not just do it the right way? So this strike them out. So 2, 1, 3, and 2. Okay. So 2 times 2, that's 4. So 4 minus 3 times 1, that's 3. Okay, so 4 minus 3. So 4 minus 3 is 1, isn't it? Okay, so that's 1. Then times the sign here, so that's 1, positive 1. So I can close my bracket here. So come to the next one, the one beneath it. Okay, so 2, for 2, we have, so strike this, strike this. So if we strike this and strike this, I'm left with minus 4 minus 2, 2 minus 1. Okay, so minus 4 times minus 1, so that's plus 4. Okay, and then 2 times minus 2, that's minus 4. So 4 minus minus, so that's 4 plus 4, isn't it? Yeah, so 4 minus minus, that's 4 plus 4. Or just to retreat, so minus 4 times minus 1, so we already said positive 4. Yeah, okay. Then yeah, positive 4. So we strike this and then we strike this. So minus 4, this, positive 4, yes. And then 2 and minus 2, negative 4. We've written that here. So yeah, 4 minus minus 4, that's 4 plus 4. So that's equals to 8, isn't it? But the place sign here is negative. So this becomes negative 8. All right, so moving on to this. So for this one, strike this and strike this. So if I'm striking this and I'm striking this, I'm left with 1, minus 2, 3, and 1. So 1 times minus 1, so that's negative 1. 3 times minus 2, so that's negative 6. And then here we have minus 1, minus minus 6, so that's minus 1 plus 6, that's 5. So this here will be 5 here. Okay, all right. So did we apply the sign here? Yeah, we did. Okay, plus 4 plus 4, 8. Okay, now moving on to this one. So strike this and strike this. So we're left with 2, 1, 3, 2. No, sorry. If we're striking this, okay, so we're striking this and striking this, so we're left with 1 minus 4, 3, and 2. So 1 times 2, that's 2, minus 4 times 3, so that's 12, so minus 12. So 2 minus minus 12, that should be 14. That should be 14 because 2 plus 12, that's 14. And the sign here is minus 14. So here I write my minus 14. Okay, now moving on. Okay, I think what okay. All right, so moving on from this. So this is 3, this is 2. Okay, so for this one, strike this and strike this. So minus 4 times 2, that's negative 8. Okay, and then 1 times minus 2, so that's minus minus 2. So this will be negative 6, isn't it? Because this becomes plus, and then negative 6 times this, so this will still be negative 6. All right, so now let's move on to next one. So next one, this is 2. So strike this, strike this. So 1 and 2. So 1 and 2. 1 and 2. So that's 2. Yes, 1 and 2 is 2. And then 2 and negative 2. So that's negative 4. So 2, that's 6. 2 minus minus 4, that's 6. So the sign here is negative, so that's the negative 6. And then lastly, for this, negative 1. So strike this, strike this. So 1 and 1, so that's 1. 2 and negative 4, that's negative 8. So 1 minus minus 8, so that's 1 plus 8, that's 9. And then the sign here is 9. So minus 5, 8, 1, 8, 5, minus 14, 6 minus 6 minus 6, 9. So the transpose of this matrix will now be the adjoint. So the transpose here will now be, so minus 5, 8, 1, minus 8, 5. Okay, so minus 5, 8, 1, minus 8, 5, minus 14, and then minus 6, minus 6, and 9. So this is my adjoint of this matrix. So it's now time for us to find the inverse of the matrix. Okay, so let's clear this part. So, okay, so clearing this part, let's clear this. Okay, so we can clear this through. So we want to compute our inverse. So after we've computed the inverse, then we can now start making sense of the equation we're having. Okay, so what do we need to do? So just multiply this by 1 over 39 because there's a negative sign here. So remember, we want to generate a new matrix. So let me just bring my matrix here. So A inverse will be equal to, so this becomes 5. Okay, so now definitely this will have to be bigger than this. The, what's it called? The matrix will have to be bigger than this. Okay, so A inverse is equal to, so minus 5 over, okay, so let me do away with the negative sign too. So because negative cancel negative, to 5 over 39. That'll be the first one. So this times this, so that's 8 over 39. So this time, okay, 6 over 39. Okay, okay. This one will be negative 8 over 39. Okay, should be negative 5 over 39. Okay, this would be 6 over 39. Okay, this should be negative 1 over 39. Should be negative, or 14 rather, over 39, and then this should be 9, or negative 9 over 39. So this is my inverse. So let's just confirm whether we've done the right thing. So again, 5 divided by this, 5 over 39, that's accurate. This 8 over 39 accurate too. This 6 over 39 accurate. This, okay, minus, yeah. This minus, yeah. This just 6, yeah. This and the, okay, so 1. Okay, so negative 1, yeah. So this just 14 over 39, yeah. And then this negative 9 over 39. So we want to use this to multiply this constant, 21, 3, and negative 2. Okay, so again, let's clear more space so that we have this is to work in. Okay, so I can clear all these ones now. I can clear this through, I guess. All right, so I can clear this through. Okay, so just clear this also. Okay, so now this is my A inverse. Okay, so of course times the constant. So remember, when we want to carry out multiplication, we already said the number of column for the first matrix must be equal to the number of row for the second matrix. So this first matrix has 1, 2, 3, 3 columns, and then this second matrix has 1, 2, 3, 3 rows. Now what happens when you switch? So let's imagine that, okay, maybe this is B and then this is A. Remember, we already said A times B in matrices is not the same thing as B times A. It's not always the same thing, actually, unless maybe it is a they're equal matrix. So they're equal matrix, then definitely, and it's a square matrix also, then definitely AB will be equals to BA. But for the sake of but if they are different orders, then AB would never be equal to BA. So that's why you can see if you reverse it, they are not compatible. Okay, so now that we've gotten the compatibility, what type of matrix are we going to be forming? So we already know we'll be forming. So the rows of this, how many rows do we have here? So this 3. How many columns do I have here? 1. So I'll be forming a 3 by 1 matrix. So I can just bring something like this here. So for the next bits here, we're just going to be using our calculator directly. So we want to multiply everything here with everything we're having down here. So I'll do 5 over 39 times 21 plus 8 over 39 times 3 plus 6 over 39 times negative. So I'm going to be pressing everything in my calculator. So I hope you can get your calculator too and also press alongside me. Okay, so starting, so 5 over 39 multiplied by 21. Okay, so plus 8 over 39, also 8 over 39. Then we multiply this with times 3. Okay, plus 6 over 39. Okay, so we multiply this with negative 2. So you can see our answer here is 3. Okay, so that's for the first one. Now for the second one, what do we do? So again, do the same thing. So minus 8 over 39, minus 8 over 39, okay, times 21, okay, plus again minus 5 over 39, okay, times 3, okay, then plus 6 over 39, okay, times negative 2. Okay, so you can see our answer is negative 5 here. And lastly we have 1 over 39. Okay, so this should be minus 1. Okay? So negative 1 over 39 times 21, okay, plus 14 over 39, okay, times 3, okay, plus negative 9 over 39, all right, times negative 2, okay, so and then my answer here is 1. So this is equal to the x, okay, x1, x2, x3. So remember we said when we have ax equals to b, where a and b are constant, then x must be equal to b dot a inverse, isn't it? Okay, so this is my a inverse, this is my b. So after multiplying them, I'm having 3 minus 5 and 1 equal to x1, x2, and x3. So that means x1 is mapping out to 3, or x1 is equal to 3, x2 is equal to negative 5, x3 is equal to 1. So this is how we solve a system of linear equation using matrices. So you can see we've done that of Cramer's rule, we've done that of Gaussian elimination, and then also we've done the matrices method. So if this series has been helpful to you, yeah, this is where we say that you should like the video, you should share the video to your friends, your colleagues, your siblings, anyone you know preparing for any exam in maths where they take calculus or even complex numbers. So because we're going to be releasing videos on topics like that. So do well to like the video, share, and subscribe. At least that way you can support the channel in that lesson. So thank you for watching, and bye bye.